Welcome to China Concept Academy. The only thing you do is to share, like, comment. Today we'll be looking at the laws of differentiation. Remember, I've taken time to explain what differentiation has changes in one variable in respect to another. I've explained the various, what is it called? I've explained general method of differentiation using various questions. Now we can actually look at laws of differentiation. Okay, now the first thing here is laws of differentiation. Okay, the first question here I am looking at is y is equal to 2x plus 4, product rule. Let's look at product rule. What does product rule mean? It involves equation that has to do with multiplication. So in this scenario, what do? All I want to do now is I will take examples to explain them properly. How do you know a question is product rule? That the examiner expects you to solve using product rule. In that scenario, the question must be in a multiplication format. So we have y is equal to 2x plus 4, 3x plus 2. This is product rule. Why? Because it involves multiplication. What do? As simple as that. I would say solution. Let u equals this. 2x plus what? 4. Let u equals this. I'm calling let this be u. So I am turning this to be u. And I'm telling them let v equals 3x plus 2. First thing foremost, let u be this and let v be this. Now, if you've done that, remember, if you've not watched the video on differentiation general method, go back to the video to understand it. What do we normally do? We pick what is on top, multiply what is below, then subtract 1. So, I want to differentiate u, tell them du over dx. I want to find changes in u in this x. And remember, in my previous video, I told us that differentiating a constant is 0. What is a constant? A number that does not have a variable. So differentiating this constant is 0. So we say this is going to be, there is power 1 here. So this is 1 times 2. X is equal to 1 minus 1. I won't differentiate 4 because 4 is a constant. So this is going to give 1 times 2 is 2, x raised to power 0. So this is both x raised to power 0 is equal to 1. My answer is 2. The same method I will do for this. I want to say dv over dx is 1 times 3, x 1 minus 1. So this is going to give me 3x raised to power 0. So anything raised to power 0 is 1. So our answer is 3. So when you have it like that, finally, all you need to do is you bring on the rule of differentiation. You remember the formula that if I want to do dy dx, that dy dx is equal to u multiplies dv over dx plus v multiplies du over dx. Okay, what is u? I already told them let u be 2x plus 4 multiplies dv over dx. dv over dx gave us 3 plus v. v is 3x plus 2 multiplies du over dx, which is 2. So let's cast this. 2 times 3x, 2x times 3 will give us 6x. 4 times 3 will give us 12. Plus 3x times will give us 6x. 2 times this will give us 4. We collect like terms. 6x plus 6x is 12x. Plus 12 plus 4 is 16. This is your answer. I'll be doing one more question that involves solve in differentiation. Now, let's take this question quickly. If you are given y is equal to square root of x plus 1 in bracket square root of x minus 1 in bracket, what do you do? Remember I told you that the first thing you do is you say let u equal to square root of x plus 1. I am calling this to be u. Then let v equals square root of x minus 1. Square root of x alone means x is equal to x is raised to power 1 over 2. So all I will do is I want to differentiate this. I will say du over dx. Square root of x means x 1 over 2. So this means x is equal to 1 over 2 plus 1. Or before I say dy dx, this u is actually this. V is equal to x is 1 over 2 minus 1. So I want to now differentiate dy over dx or du in respect to x is going to give me our normal method 1 over 2 x 1 over 2 minus 1. Now pick just this and find the LCM. Now how do I find LCM? LCM of 1 over 2 minus 1 is LCM of 2 and 1 is 2. Why is it 2? Because inside 2 we can see 1. 2 divided by 2 is 1. 1 times 1 is 1. There is minus. Bring down minus. 2 divided by 2 by 1 is 2. 2 times 1 is 2. So I'll have 1 minus 2 is minus 1 over 2. Since I've gotten the LCM, what am I expected to do? You come back here, remove this. Du over dx is now going to be 1 over 2 x is equal to minus 1 over 2. Now, all you need to do is say but. You tell them that but x 1 minus 1 over 2 means square root of this thing means is equal to 1. This thing, because of this minus sign here, negative law of indices, I will introduce 1 over root of what? X. This is what this alone means. Remember, I have not touched this 1 over 2. So what am I going to do? I will say 1 over 2 multiplies 1 over this particular thing now, root x. 1 times this will give you 1. 2 root x will give you 2 root x. I just differentiated du in respect to the x. Now, the same thing will apply whenever I'm differentiating the v in respect to the x. I will still have 1 over 2 root x. I will stop here because this is the same thing as this. The only difference is that here is plus 1, here is minus 1. So what do? I will now say the formula is dy over dx is u multiplies dv over dx plus v multiplies du over dx. What is u? My u in this question, like I told them, let u be square root of x plus 1. Dv over dx is 1 over 2 root x plus what is v? From the question I told them let v be x minus 1. Du over dx is 1 over 2 root x. What do I do here? This times this, I will have root x plus 1 over 2 root x plus this times 1 root x minus 1 over 2 root x. When I have something like this, I have the same base, I'll still find LCM. So how do I find LCM? These two things, they are the same. Now what do? LCM of these two things is still the same thing, 2 root x. 2 root x inside 2 root x, 1. 1 times this will give you square root x plus 1. There is plus here. Plus 2 root x inside 2 root x, 1. This will give you x minus 1. This goes here, x minus 1. Plus 1 will go with minus 1. Root x plus root x will give you 2 root x over 2 root x. This cancels this. Your answer is 1. This is how to solve product rule that has what is it called? That has roots. So in that scenario, that is what it is. To solve product rule that have roots, this is it. Now in my previous video, I did product rule that does not have roots. And in this video, I'm doing product rule that has roots. The next session on this video will be quotient rule and other rules of differentiation. On this note, we've come to the end of the session. See you on the next session.